Okay, next lesson is adding rational functions. Subtracting is going to work the same way, except it's going to be a subtraction. So when we are adding rational functions, we need to think about how do we add fractions. And in order to add fractions together, we need a common denominator. So for this one, we do a little bit of investigating. Always factor first if necessary, and say what does this common denominator need to be? It needs to be 5x. So what I need to do is multiply this side by x over x and this side by 5 over 5. And why that is legal mathematically is multiplying something by 5 over 5 is just multiplying something by 1. So you're not even changing anything. So 5 times 3 is 15 over 5x. 2 times x is 2x all over 5x. So you end up, now you can write it as one expression, 15 plus 2x all over 5x. And state our restrictions, x cannot equal 0. Okay, so that's how I add rational functions, common denominator. So this one here, always check and see if I can factor first. And this is all factored for me. So what do I need to do to make this a common denominator? You know what, I'm gonna do something crazy. Let's change this to a subtraction so you can practice subtraction. So let's multiply this by x plus 4 over x plus 4. And let's multiply this side by 3x plus 1 over 3x plus 1. Can you guys see that? Move it a little bit. Okay, so I do the multiplication, so on top it's just going to be 3x plus 1 all over 3x plus 1 times x plus 4, and no need to multiply out the denominator, that's not necessary, minus 5 times x plus 4 over 3x plus 1 times x plus 4. And actually, you know what I'm going to do? I'm going to actually multiply this 5 through. I'm going to write it as 5x plus 20. Okay? Now, this is the part that people mess up with when they do subtraction. Now I put it as one entire function. This is subtracting this whole thing. So when I write it out as one whole thing, it needs to be 3x plus 1 minus 5x minus 20. This negative needs to distribute to the entire thing. And then it's all over 3x plus 1 times x plus 4. So that ends up being negative 2x minus 19 all over 3x plus 1 times x plus 4. Okay, state my restrictions. X cannot equal negative a third or negative 4. So that is how I subtract rational functions. So I start off the same way, check if it can be factored, common denominator. The one thing to remember is that negative needs to be distributed. Okay? All right, so let's do one that's a lot more fun now. Okay, so let's look at this example here. Maybe I'm going to rewrite it up here so we can have some space here. Okay, so this guy needs factoring. So always start off by doing your factoring. So this guy factors to be x plus 6 times x minus 2. This factors to be x minus 6 times x plus 6 plus 5 over x plus 6. So my job when I'm doing adding rational functions is to get a common denominator. So these guys both share the x plus 6. So in order to have a common denominator, I actually only need to multiply this side by x minus 6 over x minus 6. Okay? And then we can write it as one big expression, and I'm actually going to unfactor that top just to, so I can collect like terms, plus 5x minus 30 all over x minus 6x plus 6. So I end up with x squared plus 9x minus 42 over x minus 6 x plus 6. Okay? And then x cannot equal 6 or negative 6 are the restrictions. So there we go. That's how we add rational functions and subtract rational functions.